Buffer solutions explained. What on God's green earth is a buffer solution? A buffer solution is a solution which resists changes in pH when small volumes of acid or alkali are added. Okay, so how do we make up a buffer solution? There are two fundamental ways. You can either have a weak acid and a salt, or a weak base and a salt. Let's go with weak acid and a salt. Let's say we have ethanoic acid. This acid only partially ionizes when dissolved in water, hence it's a weak acid. So CH3COOH forms CH3COO- plus H+. The CH3COO- is a conjugate base. So what this means is it's a deprotonated acid. Okay, so what else do we have? We have a salt. Let's say we have sodium ethanoate, CH3COONA. This completely deionizes when dissolved in water, and it forms Na+ and CH3COO-. So what happens when we react this with H+? So the H+ reacts with the CH3COO-, which is the conjugate base, and it forms more ethanoic acid. So the equilibrium shifts to the left, but there's a large concentration of ethanoic acid, so more can just dissociate to form ethanoate ions. So it doesn't make an overall difference to the concentration, and there are large concentrations of CH3COO- as well. What happens when we react this with OH-? OH- reacts with the H+ to form H2O, and hence H+ ions are used up. This causes equilibrium to shift to the left, okay? So more CH3COOH is produced. However, there is a large concentration of CH3COOH, so more can just dissociate to form the ethanoate ion and H+. Okay? It seems pretty simple. And essentially, we know that from the beginning, the position of equilibrium already lies to the left for the dissociation of ethanoic acid because it's a weak acid and it only partially ionizes. However, since the salt fully ionizes, it means we have large concentrations of both CH3COO- and CH3COOH, hence the pH stays constant. Okay, let's say we have a weak base and a salt. Let's say we have ammonia and we have ammonium chloride, for example. H3 reacts with water to form NH4+ and OH-. NH4+ then forms NH3 and it also forms H+. Okay, so essentially if you react H+, then what this does is it reacts with the OH- to form H2O, and then it forms more NH3. So position of equilibrium shifts to the left, and there are large concentrations of both NH3 and NH4+, so the pH stays constant. Okay, what else? So what happens when we react OH-? When we react OH-, it reacts with the H+, and then the position of equilibrium shifts to the left to form more NH4+, so the change is resisted. And that, ladies and gentlemen, is buffer solutions explained.